of yn plus f of n plus k, f of n plus k. Is the transform of f of n plus k. I have given some deductions. F of n plus k is z power k into f of z minus f of 0 minus f of 1 divided by z minus f of 2 divided by z square and so on, minus f of k minus 1 divided by z power k minus 1. See, this is a z transform of, see, z transform of f of n plus k. F of n plus k is what? F of n plus k is z power k and f of z minus f of 0 minus f of 1 divided by z minus f of 2 divided by z square minus and so on, f of k minus 1 divided by z power k minus 1. So this is z transform of f of n plus k. Similarly, here yn plus 1, this is nothing but it is similar to f of n plus 1. Okay, yn plus 1 is nothing but similar to f of n plus 1. So therefore, z transform of yn plus 1, this is nothing but z power 1. Okay, and now I define here y of z minus y0 minus y1 divided by z. See, this is for yn plus 1. Okay, similarly, z transform of yn plus 2 which is z square into y of z minus y0 minus y1 divided by z. Similarly, z transform of yn plus 3 which is z cube into y of z minus y0 minus y1 divided by z minus y2 divided by z square and so on. Okay, see, you plug these expression in your equation. Okay, and here y of z which is nothing but z transform of y of n. Okay, yn. Okay, if you know what is y of z, then you can apply z inverse for y of z, then which gives this small yn. See, this is the idea. Okay, I repeat. For the first step is apply the z transform for the given difference equation. Apply the z transform for the given difference equation, and then apply this formulas. Z of yn plus 1 which is equal to z into y of z minus y0, and z of yn plus 2 which is equal to z square into y of z minus y0 minus y1 divided by z, and z of yn plus 3 which is z cube into y of z minus y0 minus y1 minus y2 and so on. Okay, then apply the conditions. Y0 will be given and y1 will be given, and put those conditions here. Then it is simply, it will be a function of capital Y of z and some relation among the variables z. Okay, and you rewrite it, then you can get y of z is one expression. Y of z is one expression. Then apply the inverse z transform for y of z, which gives y of n. Okay, see, this is the idea, whole idea of solving the difference equation. Yeah, see, the first problem is solve yn plus 1 minus 2 times of yn equal to 0 with the condition y0 which is equal to 3. Okay, see, luckily the right hand side is 0, so therefore no need to calculate. See, this is similar to the particular integral. Suppose if the right hand side is non-zero term, then you have to find out the one more term that is similar to the particular integral. Now Now apply the z transformation on both sides. That is z transform of yn plus 1 minus twice z transform of yn equal to z transform of 0. Okay, z transform of 0. But z transform of 0 which is 0. See, therefore right hand side is 0. And then yn plus 1 z transform of yn plus 1 is what? Z transform of yn plus 1 is z trans
Z power 1 into
z power
1 into
z power y of z minus
minus y0
minus y0 minus 2 into this z transform of y of n is y of z. Okay, this is y of z equal to 0. Where z transform of yn which is y of z. Z transform of yn is yz. Now what is this here? This is z into y of z minus z into y0 minus 2 y of z equal to 0. Okay, see, therefore y of z into z minus 2 minus z into y0. What is the value of y0? Y0 is 3. See, therefore 3 equal to 0. Okay, then see, therefore our y of z is 3z divided by z minus 2. Okay, that is 3 times of z divided by z minus 2. I want what is yn. Okay, I want what is yn. See, therefore apply the inverse z transform. Apply the inverse z transform, that is z inverse of y of z equal to yn, that is equal to what? 3 times of z inverse of z divided by z minus 2. Okay, now tell me what is z inverse of z divided by z minus 2?
2 power n.
2 power n. Okay, so therefore our yn which is 3 into 2 power n. See, that is a required sequence. Okay, is it clear? Then see, next problem is solve yn plus 2 plus 6 yn plus 1 plus 9 yn equal to 2 power n. Okay, equal to 2 power n with the conditions y0 equal to 0 and y1 equal to 0 using z transform. Okay, solution. You apply the z transform, that is z of yn plus 2 plus 6 into z of yn plus 1 plus 9 into z of yn equal to z of 2 power n. Z of 2 power n. Okay. Okay. Now let capital Y of z, which is equal to z of yn. Then this becomes z square into y of z minus y0 minus y1 divided by z, then plus 6z into y of z minus y0 plus 9 into y of z equal to what is z of a power n? What is z of a power n?
So z upon z minus a.
Z minus a. Okay. See, therefore, it is of the form z of a power n. See, therefore, what is the right hand side? Right hand side is z divided by z minus 2.
A. That is 2.
Yeah, that is 2. Okay, fine. Now you multiply this inside and apply the conditions. Y0 is 0 and y1 is also 0. See, therefore, you can write it as z square y of z, and this will be 0, this will be 0, and then plus 6z into y of z plus 9 y of z equal to z divided by z minus 2. See, therefore, our y of z, which is going to be z divided by z minus 2 into here z square. Is this visible?
No, sir. Yes, sir. Now it's fine.
Yeah, z square plus 6z plus 9. This is y of z. Okay. Yeah, you please factorize the polynomial. What is z square plus 6z plus 9?
Z plus 3 whole square.
Z plus 3 whole square. See, therefore, our y of z, which is z divided by z minus 2 into here z plus 3 whole square. Okay, z plus 3 whole square. Now we can apply any method to find the sequence, but my advice is don't apply the long division method, because we cannot find out the, sometimes we cannot find out the general form of the yn. See, therefore, you can apply any other 3 methods, like partial fraction method, a residual method, or convolution method. Okay, now I'm going to apply the residue method, but in the textbook they have given the partial fraction method. Okay, I'm going to apply the residue method. What is the residue? What is the residue method?
Limit
What is the residue?
Z tends to.
See, first you have to calculate the residue of y of z into z power n minus 1, right? See, this is y of z. Y of z into z power, we have to multiply with z power n minus 1. Then find the what are the poles of y of z into z power n minus 1. Okay. Now y of z into z power n minus 1 equal to what? Z power n divided by z minus 2 into z plus 3 the whole square. Z plus 3 the whole square. Fine. Now what are the poles? The poles are nothing but what? Z equal to 2 and z equal to minus 3, and z equal to minus 3 is a pole of order 2. It is a double pole. Okay, whereas z equal to 2 is a simple pole. See, therefore, our yn, which is nothing but what? Yn is sum of the residue of y of z into z power n minus 1. Okay. See, therefore, yn is nothing but sum of the residue of y of z into z power n minus 1. Okay. See, therefore, you calculate what is the residue at z equal to 2. Residue at z equal to 2, which is nothing but limit z tends to 2 z minus 2 into y of z into z power n minus 1. See, that is limit z tends to 2 and z minus 2 into, this is going to be z power n divided by z minus 2, and z plus 3, whole square. Okay. Now you cancel this factor. Then what is this here? If I apply z equal to 2, then 2 power n divided by 2 plus 3 whole square. So therefore 25. The first residue is 2 power n divided by 25. 2 power n divided by 25. Now z equal to minus 3. See, next we have to calculate the residue at z equal to minus 3. Residue at z equal to minus 3. That is residue at z equal to minus 3. But z equal to minus 3 is a double pole. Okay, it is a double pole. See, therefore, here limit z tends to minus 3. Okay.
1 by 1 factor.
Yeah, 1 by 1 factorial into d by dz of z plus 3. Z plus 3 the whole square.
Whole square.
Z power n divided by z minus 2.
Z minus 2 into Z
Z
plus
plus
3 whole square.
Okay. Okay. Yeah. Now cancel this and differentiate this dz of z power n divided by z minus 2. Yeah, tell me what is the differentiation? Limit z tends to minus 3. What is the derivative? Z minus 2 the whole square in the denominator. Here z minus u by v rule. Apply the u by v
Z
rule.
minus 2 into
Z minus 2 into n z power n minus 1 minus z power n into 1.
1.
Okay. You please simplify this. This is limit z tends to minus 3. Z tends to minus 3. And okay, no need to simplify. Straight away we can apply the limit. Okay, if you apply the limit, what will I get here? Minus 5 n into here minus 3 power n minus 1 minus 3 power n upon, what is this here? Minus 5 whole square, right? Minus 5 whole square. See, therefore, this you can write it as a 3 power. Yeah. Yeah, see, this is the residue, right? See, therefore, minus 5 into n and minus 3 power n minus 1. Okay, minus 3 power n minus 1 and the minus of minus 3 power n divided by 25. Okay, see, therefore, your yn is going to be 2 power n divided by 25, and then minus 5 n into minus 3 power n minus 1 minus of minus 3 power n divided by 25. So this is the required yn. Okay, whereas if you apply the partial fraction method, it will be very lengthy process. See, the residue method is little easy than the others. But the problem is you should know the derivative and applying the limiting concept. Okay, then Then the third problem, solve y of k plus 2, y of k plus 2 minus 4 y of k plus 1 plus 4 times of y of k equal to 0 with y of 0 equal to 1 and y of 1 equal to 0. Y of 1 equal to 0. Okay, please note that y of k plus 2 equal to y k plus 2. Y k plus 2 and y of k plus 1 equal to y k plus 1 and y of k equal to y suffix k. Y suffix k. Okay. Or in general, you can write it as, because we are familiar with the notation, y n plus 1, y n plus 2, y n plus 3 like this. So you see, therefore, you can see the above given equation can be written as y n plus 2 minus 4 times of y n plus 1 minus or plus 4 times of yn equal to 0. Yn equal to 0. See, this is k is a dummy variable, okay? K is dummy variable. Okay, then apply the Z transform. Apply the Z transform. What you will get? Z square, the y of Z minus y0 minus y1 divided by Z. Okay, and minus 4z into y of Z minus y0. Okay, plus 4 into y of Z equal to 0. 4 into y of Z equal to 0. Fine. Now, what is the value of y0? Y0 is 1 and y1 is 0. See, therefore, this is Z square and y of Z minus 1, but y1 is 0, minus 4z into y of Z minus 1 plus 4 into y of Z equal to 0. Okay. Now, what is y of Z? The coefficient of y of Z is here, Z square minus 4z, okay, plus 4, minus 4z plus 4, and then the remaining things are minus z square. Here it is minus z square, and here it is plus 4z. Plus 4z equal to 0. Okay. Plus 4z equal to 0. Fine. So therefore, your y of z equal to z square minus 4z divided by z square minus 4z plus 4. It's okay. Yeah. Then find yn. Find your yn. Do it. Yes, what is yn? Here yn is sum of the residue of y of z into z power n minus 1. Okay. So therefore, y of z into z power n minus 1, which is what? So this is z power n plus 1 minus 4 times of z power n upon, what is z square minus 4z plus 4? What is this? Z square minus 4.
Z minus 2 whole square.
Yeah, this is z minus
Z minus 2 also.
whole square. Okay, fine. See, therefore, what are the poles? The poles of y of z into z power n minus 1. Simple. Okay. The pole of this is what? Z equal to 2. Okay, z equal to 2 and z equal to 2 is a pole of order 2. See, therefore, the residue at z equal to 2 is equal to limit z tends to 2. What is the formula?
1 by 1 factorial.
Yeah, 1 by 1 factorial
D by dy.
d by dz of
Z minus 2 whole square into
z minus 2 whole square into y of z into z power n minus 1. Okay. Yeah, see, therefore, this is limit z tends to 2 and then d by dz of here z minus 2 the whole square, and this is z power n plus 1 minus 4 times of z power n divided by z minus 2 the whole square. Now you cancel it. Okay. Now you differentiate it one time with respect to z and then apply z equal to 2. See, therefore, limit z tends to 2. What will happen if I differentiate this with respect to z? This is n plus 1 into z power n minus 4n z power n minus 1, right? Am I right?
yes sir.
Now apply the limit. See, therefore, n plus 1 and 2 power n minus 4n into z 2 power n minus 1. Okay, see, this is residue at z equal to 2. See, therefore, our yn, which is this n plus 1 2 power n minus 4n into 2 to the power n minus 1. So this is the required sequence. Okay, then see, next problem. See, in the last 3 problems, the indices were always positive. See, for example, n plus 1, n plus 2, n plus 3. Sometimes they will give you, say, for example, n minus 3, n minus 2, n minus 1, n like this. First, you have to convert them into the positive indices like n plus 2, n plus 3, n plus 4 like this. Okay, that is the next problem, next type of problem. This is the 4th problem. Solve yn plus 3 times of yn minus 1 or y of n. Y of n plus 3 times of y of n minus 1 minus 4 times of y of n minus 2 equal to 0 for n greater than or equal to 2. Given that y of 0 equal to 3 and y of 1 equal to minus 2. Y of n equal to minus 2. Okay. You replace n by n plus 2 in order to make that as positive indices. Replace n by n plus 2. See, therefore, you will get n here, and then here it will be replaced as n plus 1, and here it will be replaced as n plus 2. See, therefore, solution. Replace n by n plus 2. N by n plus 2. Then what you will get here? Y n plus 2, y of n plus 2 plus 3 times y of n plus 1 minus 4 times of y of n equal to 0. Here n which is greater than or equal to actually 0. Okay. Now y of n plus 2, which is y suffix n plus 2, and y of n plus 1, which is y suffix n plus 1, and y of n, which is yn. Y of n equal to yn. Now apply the z transform on both sides. Then you'll get z square into y of z, z square into y of z minus y0 minus y1 divided by z. Okay. Plus 3z into y of z minus y0 minus 4 times of y of z equal to 0. Minus 4 times of y of z equal to 0. Okay. You collect the coefficient of y of z and write down what is your y of z. Y of z into here z square plus 3z minus 4. Then what is y0? Y0 is 3. See, therefore minus 3z square, and y1 is minus 2. Y1 is minus 2. See, therefore plus 2 plus 2z. Okay, plus 2z. Then here y0, which is 3. See, therefore minus 9z equal to 0. Minus 9z equal to 0. Yeah, see, therefore what is y of z? Y of z equal to 3z square, and then this will be plus 7z divided by z square plus 3z minus 4. Okay. Yeah, please find out what is y of n. Please do it and tell me what is yn. So what are the poles? Guys, what are the poles? Or you please factorize the denominator polynomial, or what are the roots of the denominator polynomials?
So plus 4 and minus 1.
Plus 4 and minus 1 or minus 4 and plus 1?
-4 + 1.
Minus 4 plus 1.
Yeah, poles are minus 4 and plus 1.
Yeah, poles are minus 4 and plus 1. Okay. See, they are simple poles. Okay. See, therefore, you have to calculate two residues. Residue at z equal to minus 4 and the residue at z equal to 1.
For z equal to 1, residue was 2.
Simply 2. Okay. And what about the residue at z equal to minus 4?
So is it minus 4?
Minus 4? Simply minus 4. Hello?
Yes,
Yes,
sir.
sir, it's -4.
Minus 4.
Not it is not simply minus 4. It is minus 4 power n. Minus 4 power n.
So we are not getting, sir.
You're not getting minus 4. Have you multiplied? Have you
Sorry,
multiplied?
so we didn't multiply it with z power n minus 1.
Ah,
Yeah. Then
you
we'll
have to
get minus 4 power.
yeah, you have to multiply it by z power n minus 1.
Yeah, sir.
Yeah. Tell me what is the answer now? What is your yn? Anyone, please? What is the answer?
So 2 plus
Ah,
minus 4 power n.
yeah, 2 plus minus 4 power n. Okay, so that is the answer. Okay, then the next problem. So the answer is 2 plus minus 4 raised to n. So this is the answer. The next problem, solve yn plus 2 minus 7 times of yn plus 1 plus 12 yn equal to 2 power n with y0 equal to 0, which is equal to y1. It is very simple. Please do it. Yeah, what are the poles, students? So anyone, please? What are the poles?
Wait, sir.
So 4 and 3.
4
3.
and one more thing. There are 3 poles. Z equal to 2, Z equal to 3, and 4. There are 3 poles. Isn't it?
So is it cubic equation or
Quadratic equation only.
so then we'll get 2, right?
No. See, right hand side, what is right hand side? Right hand side is 2 power n, you know?
Sir, right hand side Z upon Z minus 2. It will be.
Yeah, Z upon Z
Okay,
minus.
so I got. Okay.
See, that gives another pole, Z equal to 2.
Yes, sir. Z equal to 2, 3, and 4.
Yeah. They are simple pole. Luckily, they are all simple poles. Therefore, we just substitute Z equal to 2, Z equal to 3, Z equal to 4 in the form Z minus 2 into f of Z into y, Z power n minus 1, and Z minus 3 into y of Z, Z power n minus 1, Z minus 4 into y of Z, Z power n minus 1. Okay. See, these are the residues. And you please check that your yn equal to 2 power n divided by 2 minus 3 power n plus 4 power n by 2. Okay, this is the required answer. Okay, see that your yn is, please verify that it is yn equal to 2 power n divided by 2 minus 3 power n plus 4 power n by 2. So this is your solution. Okay.
Okay, sir.
Okay. So this I close the session. Number 13, Muhammad Baba. Number 13 is here. Number 13, 1-3. See, today lecture, today video will be saved in your Google Drive. Okay, you please change the setting and share it to me.